Hi, this is a video for review on vectors. Let's first talk about the basics of vectors. A vector is denoted by an arrow. The length of the arrow gives you the size, that is the magnitude of the vector, and the arrowhead gives you the direction of the vector. Okay. A vector's direction can be indicated in different ways. How do you indicate the direction of the vector? One is using bearing notation. Say if the vector is 45 degrees away from north towards northeast, then you say that this is 45 degrees northeast, right? This is the method of indicating vector in bearing notation. Okay, the next type of representing a vector is using coordinate plane. You place the vector at this by this way, so that this is on the origin, and the vector shows the direction as usual. This is the direction, and when it is in coordinate form, the vector has two components. One is angle. Okay, it is denoted by the angle from which the vector is away from the x-axis. Okay, so the angle of the vector from the x-axis is one component, and the length of the vector is the other component, which is, if this is y units and this is x units, the length of the vector is given by x square plus y square in coordinate form. Okay. What are the notations that are used to denote a vector? Let's say there is a vector a. So if it's a vector in small letter, then we represent it as vector a with an arrow above the letter, or with a sign like this above the letter, or even below the letter. Okay, so there are actually different ways of writing a vector when it's given in small letter. Okay, you can write it in any of these three methods, and if you know the starting point and the end point of a vector, then you can represent this vector as OA with an arrow on the top. O is the initial point and A is the final point. So initial point, final point with the arrow on the top. What is a position vector? You can draw the coordinate axis like this, so that the start of the vector is on the origin of the axis. Okay, if this is placed like this, then it is the vector OA is called the position vector. Okay. What is the magnitude of how do you represent, what is the notation for the magnitude of the vector? You just put the sign of like absolute value. It is not the absolute value, but this is the magnitude which gives you the size of the vector. Okay, so you can also represent it as modulus of a, or modulus of a like this, or but this is the notation used for magnitude of the vector. How do you do addition of two vectors? Say there are two vectors a and b which start from the same point, or the other situation is where the second vector starts from the end of this first vector. So there are two situations here when you are going to add two vectors. So in the first case, you complete the parallelogram and get the diagonal, and this diagonal is actually a plus b. In the second case, this is a plus b, the vector which completes the triangle, that is going along the a, along b, and starting from the start point of a and the end point of b gives you a plus b. Okay, actually they are not two different cases, they are the same. For if you can notice this, in the first case I can shift b towards this place, and this is again b because they are equal and parallel, and still you can see that we are actually using the triangle case to find a plus b, right? A here and b here, and this is a plus b, and in this triangle case it actually can be used as parallelogram case. See, if I shift the b here and if I complete the parallelogram, the diagonal, which was the case for parallelogram, becomes the a plus b. So you could have noticed that the green arrows did not change any place, but you can use either case in either way. It's just understanding how the two vectors are placed and where the resultant vector would be. Okay, resultant vector means the addition of two vectors. Okay, now how do you subtract two vectors? For subtraction, you need to know something known as negative vector. If I have a vector a, okay, negative a would be a vector which is like this. This negative a and a vector has the same magnitude, but they are in the opposite direction. Okay, so a and negative a, they have same magnitude but opposite direction. Now how do you subtract two vectors? Say I have here two vectors, and this is a and this is b, and I am going to find what is a minus b. Instead of a minus b, I can actually write it as a plus minus b, or I can also write it as minus a plus b. Let me see which one works out. So basically I need to find the negative of b. So let me take the negative of b, same magnitude, opposite direction, and let me shift it here so that I can make a parallelogram and find the resultant of a and minus b. So resultant of a and minus b would be minus b plus a. So this is a minus b, right? So this vector, which can be actually placed there, is a minus b. Okay, so you can notice that if I have this as the origin, and if this is a and if this is b, a minus b is actually ba, because this is how it goes, and this can be written as oa and this can be written as ob. So you can see that ba, which is a minus b, is nothing but oa minus OB, where OA and OB are the position vectors. So any vector x, y can be represented in the form of position vectors, like it can be written as OY minus OX. Remember that the first vector would be the position vector of the end point, and the second vector would be the position vector of the starting point. So this BA starts from here and ends there. So it is B to A. So it is end point is A and the starting point is B, therefore it is OA minus OB. How do you multiply vectors? There are two cases in multiplication. One is scalar multiplication, the other one is vector multiplication. First, scalar multiplication. This is nothing but multiplying a vector by a scalar, okay, by a number. Say I have a vector A which has 12 units of length, okay. Now if I make 2A, you can see that it is in the same direction, but the length becomes 24 units, right? So the length of 2A is 24 units, but in the same direction. What about half A? I can multiply A by another number half. So what would be half of A? It will be in the same direction, but the magnitude would be just 6. That is half of the original magnitude of A. Now what happens if I multiply by a negative number, say negative 3? Obviously the direction changes. Okay, the direction changes, but the magnitude is the same as if you would have multiplied by a positive number. So you can see that there are 3 units of the original one, which is now 36 units. So negative 3a and 3a has the same magnitude, but they are in opposite directions. So you can multiply a vector a by a scalar. This scalar can be anything, right? Any number of the real values. Okay. Vector multiplication. This is for multiplying two vectors. Say this is a and this is b. So how do you multiply two vectors? There are two methods. The first method is dot product or scalar product. For this we need the angle between the vectors. Okay. So a dot product is done like a dot b, and the definition for this is modulus a modulus b cos of the angle between a and b. So what's modulus a? And this is modulus a, and this is modulus b, and cos of the angle between them. This is the definition for a dot b. You can see that the final value is a number. Modulus a is a number, modulus b is a number, and cos theta is a number. So finally we are getting it as a scalar quantity. That's why the name scalar product. Okay. Now let's look at what is vector multiplication. Okay, vector multiplication is again another way of multiplying two vectors. Say I have a vector a and vector b, and their modulus is here, the length of vector b and the length of vector a, and I have theta in between them. Then the vector product, otherwise known as cross product, a cross b, is modulus a modulus b sine theta, and there is a vector n cap attached to this, multiplied by the vector n. The vector n is a unit vector, but the direction is it is normal to the plane containing both the vectors. I'll just explain that in a few seconds, but you can see that this part of the definition gives you a scalar quantity, right? It's just a number, but this is the only vector that actually specifies the direction of A cross B. Therefore, A cross B is in the same direction as the direction of the vector n. So what is the direction of the vector n? So let's make this two vectors lie on a plane. Say I'm going to put them on a single plane, and this is vector A and this is vector B. And what is vector A cross B? Would be the same as the vector n here, which has the same magnitude as same direction as vector n, but it has a magnitude of modulus A modulus B sine theta. So where is this n placed here? So if you just see, I told you this is the normal to the plane. So the normal is always perpendicular to the plane. It could be here or it could be here. So which one to take? If you want to take this direction, then you need to see which direction you are going. We can actually go from A to B or from B to A. You can see that A to B is anti-clockwise and B to A is clockwise. Okay, so there is a thumb rule for this. If you put your hand like this, and this is anti-clockwise, so when you go from A to B, that is when you use this anti-clockwise direction, so A to B, A cross B, then you have the direction of A cross B to be on this side. On the other side, if you have if you consider B cross A, which is clockwise direction, you can see that this is clockwise direction. If you consider it in clockwise direction, the answer would be on this side, which is actually B cross A. If you start from B and move towards A, then the direction of the normal would be on this side. Therefore, this is A cross B, and this is B cross A, and this is A cross B. You can notice that A cross B is the same magnitude but opposite direction of B cross A, which is negative of B cross A. Okay. And dot and cross product, what are some of the properties? A dot B equal to 0. What does it mean? Modulus A modulus B cos theta equals 0, right? It's obvious that modulus A and modulus B are not equal to 0 because we are considering non-zero vectors. So the only possibility is cos theta equal to 0. When is theta equal to 0? Sorry, when is cos theta equal to 0? When theta is 90 degrees. That is when the two vectors are perpendicular to each other, then the dot product is equal to 0. What happens when cross product is equal to 0? This is modulus A modulus B sine theta n cap equal to 0. Obviously these two are not 0 and this is not 0. Therefore the only possibility is when sine theta equal to 0, which means that theta is 0 degrees, which means that A is parallel to B. The vector A is parallel to B, and here the vector A is perpendicular to vector B. So when is A dot B equal to modulus A modulus B? So in this case, this cos theta is not to be seen, which means that it is equal to 1. Cos theta equal to 1 when theta equal to 0 degrees. And when is A cross B equal to modulus A modulus B, which means that sine theta equal to 1. This happens when theta is 90 degrees. That is when A is perpendicular to B. Right? You can notice that A is perpendicular to B when A cross B is modulus A modulus B, or when A dot B equal to 0. And A is parallel to B when A dot B equals modulus A modulus B, or when A cross B equal to 0. These are very important results. What is modulus of A dot B? A dot B by itself is a scalar, so you can't find the modulus of a scalar. Modulus is not the absolute value. This is the magnitude of a vector, so you can't find a magnitude of a scalar, so this is not possible. What is modulus of A cross B? This is modulus of A, modulus of B, sine theta, and modulus of n cap, which goes off because this is equal to 1. So this is actually modulus A, modulus B, sine theta. So what does it mean geometrically? So if you have two vectors A and B here, and if I draw the perpendicular, and if the angle between them is theta degrees, and you can see that this would be modulus B, and this would be modulus b sine theta, right? Because this is theta, this is hypotenuse, and because this is 90 degrees, so this the blue line would have the length of modulus b sine theta. What is the blue line? The blue line is nothing but the height of the parallelogram, and this is modulus a, which is the base of the parallelogram. So what happens here is modulus a modulus b sine theta, which is modulus of a cross b, is nothing but the base times height of a parallelogram, which is the area. Okay, therefore modulus of a cross b gives you the area of the parallelogram whose adjacent sides are a and b. Okay, so if you want to find the area of the triangle whose adjacent sides are vectors a and vector b, then you will have the area of the triangle to be half of modulus of a cross b. This is again another important formula.